Now what they are asking us here, A part in this question. What they are asking us here in A part of this question. Sketch the PV and TS diagram. So as usual, what we are going to do, we are going to leave this space for the PV and TS diagram. So always leave this space. Then after that, start writing down the given things. So first of all, what? A pressure volume diagram. And after that, we will have what? A temperature entropy diagram. That is what? A TS diagram. So PV diagram. After that, we will have what? TS diagram. Okay, just we will leave this space and then we will start writing down the given things, what they are saying in the given things. Now we have R, we will write down R at the end of the after writing. R, they have given us a R, they have given us a gamma. So R is 0.287, gamma is 1.33, expands reversibly in a cylinder according to the law. Expands reversibly, what they are saying? So our first process is what? There is a what they are saying? Expansion. Expands. Meaning of this word expands means what? Expansion. Reversibly, I told you. We discussed what? All the processes in this chapter are reversible. So irreversibility is 0. Reversibly, according to the law, PV raised to the power 1.48 constant. So whenever they said PV raised to the power 1.48 constant, it means what? Which process? PV raised to, not PV constant. PV raised to the power n is equal to constant. PV raised to the power n equal to constant means what? Process 1 to 2. PV raised to the power n is equal to constant. It is expansion. So whenever they give this word PV raised to the power n constant for that particular process according to the law, it means what? This process will be what? This process will become what? A polytropic process. What it will become? Polytropic process. So polytropic in which? What will be that one? Polytropic expansion. And which law we are following? PV raised to the power 1 point how much? 48 is equal to what? Constant. PV raised to the power 1.48 is equal to constant. So we have a first process. After that, what they are saying? Process 2 to 3 is what? Process 2 to 3 is what? Constant volume. Process 2 to 3 is what? A constant volume. Then heated at a constant volume. When they said they heated at a constant volume is what? Constant volume heating or constant volume heat addition. So process 2 to 3 is what? Constant volume heat addition. So before going further, please write down the names of these two processes. First of all, please write down the names of these two processes. Now then after writing the names of processes, what we have to do? After writing the names of processes, how many states we have here? Two processes means what we have here? 3 states. So for 3 states we are going to write down the properties. So for that purpose we are going to form a table. P1, P2, P3, then what? T1, T2, T3, and then what? P1, P2, P3. In this way we are going to form a table. Now what are the things we have here? So we will start writing down the, so what they said, the initial pressure. See the things here further. What they are saying, the initial pressure is what? 88 bar. So this 88 bar means what? What it will become? 88 bar means what? P1. So P1 is what? Our 88 bar. But what is favorite unit for this chapter we have? What is the favorite unit for this chapter? For favorite unit for this chapter is kilonewton. How to convert bar into kilonewton per meter square? It is not a 10 raised to the power 5. It must be what? 88 into 100. See, remember, 1 bar means what? 10 raised to the power 5 Newton per meter. and 100 kilonewton per meter square. So 1 bar means what? So 88 bar means what? How much kilonewton per meter square? 88 bar. 8800. It will become how much? 8800 kilonewton per meter square. So we got a value of P1. 1 minute. Let me make the partition here so that things will become very easy. After that, after a P1, what we have? Initial temperature 1727 degrees Celsius. So 1727 degrees Celsius means what? T1. 1727 degrees Celsius. But what is our favorite thing? In temperature Kelvin. How to convert degree Celsius into Kelvin? We have to add what? We have to add what? 273. So 1727 plus what? 273. It will become what? 2000 Kelvin. After that, what they are saying further? Final pressure. Final pressure means what? What is our final point here? P3. So final pressure is what? 1.5 bar. So P3 will become what? 1.5 bar. But we have already discussed what is favorite unit of the pressure. So it will become what? 150 kilonewton per meter square. After that, the final volume is 20 times the initial volume. What they are saying? Final volume is 20. So what is our initial volume? V1. Final volume is V3. So V3 is what? 20 times V1. And here remember what they are saying. What is process 2 to 3 we have? What is process 2 to 3? So process 2 to 3 is what here? Constant volume heat addition. Means constant volume process. So can we say V2 is equal to what? V3. So V2 is equal to V3 we have. And then V3 is what? 20 times V1. So can we say V2 is equal to 20 times V1? Can we say? Then after that, they have given us R. Value of R is what? 0.287. What is the value of R they have given us? Value of R is what? 1 minute. So what is the value of R we have here? Value of R they have given us 0.287 kilojoule per, and then they have given us a value of gamma. What is the value of gamma they have given us here? See this value of gamma 1.3. And we already discussed whenever we should have in the beginning only Cp, Cv, R and gamma. Out of that 4 properties we have R and gamma. How to get the value of Cv? So Cv will become what? R upon gamma minus 1. So R is what? 0.287. Gamma minus 1 will become what? 0.33. So what will be the value of Cv? 0.287 divided by 0.33. How much value we are getting? 0.287, 0.8697. Calculate once again. So, and what will be the unit of Cv? Kilojoule per kg Kelvin. And then we will get a what? Then next is what we will calculate? Cp. Cp is what? Gamma Cv. Okay, we will get a straightforward if you use gamma is what? 1.33. Cv is what? 0.8697. So it will become what? 1.33 multiplied by 0.8697. How much it will become? 1.67 unit kilojoule per kg Kelvin. So before going further, now here we will say this is for point 1, this is for the point 2, and this is for the point 3. Point means state here, we will say state. So please complete this discussion before going further. Now what is remaining? So we will start, after writing all the given things, we will start with what? A PV diagram. What is process 1 to 2? We have process 1 to 2 is what? A polytropic expansion. Now what is polytropic expansion? Polytropic expansion means what? Decrease in pressure, increase in volume. So this will be what? Our polytropic expansion. So 1 to what? 1 to 2. So 1, we will have what? A 1 to 2. So this is what? A polytropic expansion. And we will denote polytropic process here how? PV raised to the power what? What they have said? 4 equal to constant. So this is what? Our polytropic process. Now what is 2 to 3 process? Tell me, what is 2 to 3 process? Constant volume heat addition. Constant volume heating means what? A pressure constant, volume constant, straight vertical line upward, but it will not go above the point 1. Remember this point. Why it is not go above the point 1? Why it will? See, correct. See, you are saying correct. Final pressure is what? So here what you are saying? Final pressure is what? 1.5 bar and initial pressure is 88 bar. So 1.5 bar is what? Less than the 88 bar means, suppose if you draw one dotted line from here, this point pressure is what? 88 bar. And what is the pressure of point 3? What is the? So means what? A point 3 must be below the point 1. So here 1.5. You are getting my point? Any doubt in this discussion? And if you extend this line, this dotted line further, what we can say? If you extend this dotted line further, what we can say here? Here we can say V2 is equal to what? Volume of 0.2 is equal to volume of 0.3. So please draw this PV diagram now. Now next point will be what? See, now what is remaining? TS diagram. But what we discussed earlier, whenever we have a polytropic process, whenever we have what? A polytropic process, for polytropic process we don't know exact TS diagram. So what we will be going to do, we are always going to draw TS diagram for polytropic process at the end.
Yes.
So now what is they are asking us in B's first part? Temperature after expansion. What is our expansion process here? 1 to 2. So after expansion means what? Point number 2, after expansion point means what? Point number 2, temperature after expansion means what? It will become what then? Temperature of what? Point 2. So in B's first part, what they are asking us?
Temperature of point 2.
Temperature of point 2, that is what? A T2. And how to get a T2? For that purpose, just observe this one. We have what? Process 1 to 2. What is process 1 to 2? What is process 1 to 2? Polytropic
expansion.
So now what is the relation between temperatures and volume? What is the relation between temperatures and volume?
Temperatures and volume.
Temperatures and volume, what will be the relation here?
Directly proportional.
What is the relation for polytropic between temperatures and volume? Temperature and volume for a polytropic process. Equation of state.
Yeah, T2 upon T1
okay, 1 minute.
is equal to V1 upon V2 n minus 1.
Raised to the power n minus 1.
Yes.
So for process 1 to 2, what we will write down? T2 by T1.
T2 by T1 is equal to V1 by V2.
V1 by 2 raised to the power what?
N minus 1.
N minus 1. So T2 will become what? T1 into what?
V1 by V2.
V1 by V2. So how much V1 we have? If you observe here.
So V1 we have to consider just V1 only.
Yes, right? V1 by V. And V2 is what? 20 times V1?
20 times V1. Yes.
20 times V1. N minus 1 will become what? N is how much? We have
N will be same like gamma 1.33.
No, not a gamma. Don't take first of all, remember, gamma is a different thing. N is a different thing.
Yeah, 1.48, sir. 1.48. N is
so
equal to 1.48.
N is 1.48. So
Yes.
so it will become 0.48. So T1
Yes.
is how much? We have a 2000. And it will V1 will get cancelled out. So this term will become what? 1 by 20 raised to the power 0.48. If you do the calculation, how much value of T2 we will get? Try to do the calculation.
Yes. Raised to the power of 0.
How much value we are getting?
So 1 minute. This the power that you have written. Okay, 0.4. Perfect. My mistake. Yeah, we are getting 474.827.
8272 Kelvin. Okay. So in this way, what we got it?
We got the temperature T2.
We got what? We got the temperature T2 474.88272. So here answer is also there. Okay. So here we got a T2. Please write down this discussion
on the table.
And we will, once we got this value, very good. So once we got this value, what we will do?
We will write it in the table.
474.8272 Kelvin. And the use of this writing in the table is what? Things will become very easy. Very, very easy.
Yes. Okay.
So please write down this one, this first part.
Yes, sir. Done, sir.
So this is what they are asking. So this is what temperature after expansion. Now in this third part, what they are asking us? Final temperature. What they are asking us? Final temperature. So in this second part, our target is what they are asking us?
T3.
T3. Final temperature means what? Final point, and final point is here T3. Now if you observe here, how to get a T3? See, we will take generalized equation of state, that is P1 V1 by T1 is equal to P3 V3 by T3. We will take that generalized equation of state. See, what is that one? P1 V1 generalized equation of state, P1 V1 by T1.
Yeah.
P3 V3 by what?
T3.
T3. So how much T3 we will get? P3 V3 T1 divided by what? P1 V1.
Yes.
Then P3 is how much we have? How much value of P3? 150.
150.
P3 is how much we have? 150. V3 20 times V1.
Yeah.
T1 2000. P1 8800. And V1 is unknown. So this V1 and this V1 we can cancel out. And in this way we will get a temperature of 0.3.
Yes.
So please do the calculation and try to get the value of temperature of 0.3.
681.818.
1 minute, let me calculate this one.
Yes, sir.
800. How much?
81.82. 8181. 81.818.
1 minute. I made a mistake here. This is 150. So 681.818.
818.
8181, or can we take 82, this one?
Yes, perfect.
So here in this way we got a final temperature. And after getting this one value, what is our next target? Write down this one put it in the table. The things will become very, very easy. 681.8182 Kelvin. Add this one into table. Add it to the table.
Yes.
Now please write down this discussion about T3. Now then what they are asking us in this third part?
The net heat transfer per kg.
See, if you remember our discussion in last numerical, if you remember our discussion from last numerical, that is question 1, what we did in question 1, after writing down all the given things, we calculated the mass in question 1. That is what we did in question 1. If you remember our discussion from question 1, so what we did, we calculated the mass M 0.3484. That is what we have done. But here, if you remember, does we calculated mass here?
No.
Why we have not calculated? Because it is not possible for us to get the mass. Because if you observe all points, point 1 or point 2 or point 3, does we have all properties of any point? Don't consider 20 times V1 is not property. Means it is they have given only ratio here. But actual volume they have given us for any place?
No.
So here we can't mass in the beginning. And that's why if you read the question carefully, what they said, per kg basis. See the wording here. What they said, net heat transfer per kg. So what will be unit will become then? Kilojoule
per kg.
Per kg. Net heat transfer. Net total. All the things are the same here. So net heat transfer or total heat transfer they are asking us. So it will become per kg basis. That is what our target. So what we have to find out? Net heat transfer per kg. And how to get a net heat transfer per kg? Here we have what? Two processes we have. So Q net will become what? We should have 1 to 2 plus
Q2 to 3.
Q2 to 3. So what is the Q1 to 2? What is the process 1 to 2? What is process?
Polytropic.
Polytropic process. And if you remember what is the heat transfer for a polytropic process, we will go to the polytropic discussion. Heat transfer.
Delta U plus W.
So Q will be what for polytropic process? See the polytropic we have seen. Delta U is equal to delta U plus W. So that is what we have seen. So Q1 to 2 will become what? Delta U 1 to 2
plus W.
Plus W 1 to 2?
Yes.
So then what it will become what? Q1 to 2. Delta U 1 to 2 will become what? M CV
into T2 minus T1.
T2 minus T1. And W1 to 2 will be what, sir? M into R for polytropic process. What?
MRT.
Which one? T1 or T2?
T1 minus T2.
See work done here, T1 minus T2. So see the scenario. And divided by what?
Divided by N minus 1.
Divided by N minus 1. So we will put the all values. Mass, how much mass we have to consider per kg basis?
1 kg.
1 kg. CV, how much we got it in the beginning?
CV we got around 0.8697.
97. T2, how much we calculated? T2, how much?
T2 we calculated 474.
474.8272. 8272 minus T1. 2000 Kelvin they have. Plus
2000 Kelvin.
Plus M is 1 kg, R is 0.287. T1 2000 minus T2 474.8272 divided by N minus 1 will become what then? 0.48. N is what? 1.48?
Yes, N is 1.48.
Okay. So 0.48. So please do the calculation and try to get the value of Q1 to 2.
Okay, so
How much value we are getting?
Which? So we are getting minus 888.718.
How much we are getting? Check it once again.
Oh, just a moment.
Let me check my previous value. I have previous value also.
No, sir. You are right, sir.
How much? Minus 414.5165. Minus
Yes,
414.5165 unit kilojoule per kg.
Yeah.
So we got a value of Q1 to 2. Then process 2 to 3 will be what? Constant volume heating, constant volume process. And what is the relation of heat transfer we have seen for the constant volume? What is the relation we have seen? Go to the constant volume one. What is the relation?
Constant volume, sir, we have a heat transfer M into CV T2 minus T1.
See, constant volume, for constant volume, which relation we have seen? mCV T2 minus T1. So we will come back to the question. So instead of T2 minus T1, what we will say? mCV
T3 minus T2.
T3 minus T2. So mass is how much? 1 kg. CV is what? 0.8697.
Yes,
T3,
sir.
T3 how much we calculated? 681.
Yes, 681.8182.
681.8182. T2 is what? 474.8272. And if you do the calculation, we will get what? Value of Q2 to 3. Please do the calculation.
One 180.02.
180.02 unit kilojoule.
Kilojoules.
Kilojoule per kg. Why we are per kg? Because per kg basis they say. So we got, and then what we will become? Q net will be what? Q1 to 2 plus what? Q1 to 2, how much we calculated? Minus 414.5165. Q2 to 3, how much we calculated? 180.02. So how much value of Q net we will get? Please do the calculation. Minus 414.5165 plus 180.02
minus 234
minus 234.49.65 unit kilojoule per kg. And we already discussed, whenever we will get a minus value, we will write down what?
Rejected.
Positive value. And then what we are going to do?
Heat is rejected.
We will write down heat rejection. What we will do? We will write down the value heat rejection. So please write down this discussion.
Done, sir. Little bit up.
So in this fourth part, what is our target? What we have to find out?
Specific entropy, small s.
Delta S what? Net. And delta S net will be what? Delta S 1
to 2
plus delta S 2 to 3.
Yes.
That is what our target?
Yes.
So what is delta S 1 to 2? Will become what? 1 to 2 will be what? What is first relation we have what?
1 to 2 we have polytropic.
So it will be what? Generalized one? M. C.
Now over here we have delta S, that is in terms of your entropy relation. But over here they are asking for the specific entropy. So we have to divide it by mass.
Mass means we will take mass 1 kg then here.
Yes.
mCV.
So then it will be entropy.
Okay, mCV specific they said now. What they say? Net change in specific entropy. What they are saying here? Net change in specific entropy. You are getting my point?
So delta S divided by mass, that will be the specific entropy, correct?
But instead of, so it means what? We will take directly 1 kg here.
Yes, sir. Over here it is given as 1 kg. That's why if it's not given, then we have to divide it, right?
Why you have to divide, sir? Okay, it is not given. Then see whether it is a given or not, whether it is a mass given or not. Just if they are asking a specific, means take a mass 1 kg directly, sir, and do the calculation on that basis. Whether it is a, means suppose in previous question also, if they are asking us, means unnecessary, if they are asking us just specific, then why to take unnecessary mass? Just take 1 kg.
Okay.
mCV ln T2 by T1 plus R into ln what? V2 by V1
plus R ln V2 by V1.
So we will put all values. Delta S 1 to 2. Mass is what? 1 kg. CV is how much? 0.8697.
Yes.
8697. ln of T2. T2 how much we have in the table? 474.8272.
Yes.
8272 divided by T1 2000 plus R 0.287 into ln of what? 20 times V1 divided by V1. So V1 will get what? Cancel out here. And we will get what? Delta S 1 to 2. Please do the calculation, and delta S 1 to 2 will be what? So 0.8697 into ln of 474.8272 divided by 2000 plus 0.287 into ln of 20. How much value we will get? Minus 0.3908 unit kilojoule per kg Kelvin. So specific we got it. After that what we are going to do? After that what? Delta S what? 2 to 3. What is 2 to 3 process here we have? What is 2 to 3?
We have a constant volume.
Constant volume what? Heat addition?
Yes.
So M?
CV ln T2 by T1.
So instead of T2 by T1 what we will see here? T3 by T2?
T4. T2 yes.
Okay. T3 by T2 mass is what? 1 kg. CV 0.8697 into what? ln of what? T3 is how much we have? How much T3 we calculated? 681.8182.
Yes.
681.8182 divided by T2 is how much we have? 474.8272. So in this way we will get a value of what? Delta S 223. So please do the calculation.
0.3146.
0.8697 into ln of what? 1 minute. Into ln of 681.8182 divided by 474.8272. How much it will become? 0.3147 kilojoule per kg Kelvin. And they are asking us delta S net. And what is delta S net will become? Delta S
minus 0.076.
This one?
Yes.
0.8697 into ln of 681.8182. This one, this value?
Yes, sir. That delta net.
Okay, you are telling me delta net. Okay.
Yes.
Delta S 1 to 2. So delta S 1 to 2 how much? Minus
0.3908
plus 0.3147.
Yes, sir.
And then delta S net will be what?
Minus 0.07613.
Minus 0.3908 plus 0.3147. So it will become minus 0.076 kilojoule per kg Kelvin of specific. So here it means whenever we are getting value of delta S negative, it means decrease in entropy.
Yes.
So before going further, please write down this discussion.
So a little bit up. So over here we don't need to write the delta S in positive and it's decreasing something.
No, here it is not necessary.
Okay.
Here it is not necessary to write down positive value and decrease in entropy.
Okay. Done, sir.
Now what is our remaining in this question? What is the
The
name?
diagram.
TS diagram, temperature entropy diagram. Now tell me,
Yes.
for process 1 to 2, what is happening? For process 1 to 2, what is happening here?
It is reducing. Entropy is reducing.
Process 1 to 2, entropy is decreasing. How does we come to know that entropy is decreasing?
The sign is negative.
Because delta S 1 to 2, we got it negative. So we got delta S 1 to 2 what? We got it negative. So entropy is reducing. And what about temperature? 1 to 2.
Temperature is also reducing.
Temperature is also reducing. Means entropy reducing, temperature also reducing. So how will be the scenario here? So how will be the scenario?
It will be an inward curve, yes.
Okay. So curve will be what? How will be the curve? Temperature, entropy both are reducing.
Yes.
So here, so this will be what? 1
to 2.
1 to 2. Now we will, what about what in 2 to 3? What is happening in 2 to 3?
So 2 to 3, your temperature is increasing and entropy is also increasing.
Okay, 2 to 3, it is definitely happen, guys, because it is a standard curve. So 2 to 3 is what? A standard one. So now, so see the point here. What is the slope of 1 to 2? A slope for 1 to 2 will be what? If you remember our discussion from last lecture, from the question 1, slope for 1 to 2 will be what? Delta S1 to 2 is how much we have? How much delta S1 to 2? 0.
Minus 0.3907.
We will take a directly positive value, 0.3908. And temperature, sorry, we will take a temperature Y2 minus Y1. So temperature 2000 minus what? 474. We will take approximate value divided by what? How much we will have? Delta S1 to 2. 0. How much?
0.3908.
0.3908. See the things here carefully. So how much value we will get for slope? 2000 minus 474 divided by what? 0.3908. How much value we will get?
3904.
3904. Okay. Slope 2 to 3 will become what?
390. Slope 3 to 1.
The slope 2 to 3. We will see what? A temperature 681.
682 minus
681. 681 na?
Yeah.
81 minus 474. We will take approximate value divided by what? Delta S2 to 3. 0.3147.
3147.
So 0.3147.
62599. 626.
62599.
99.
Okay. 1 minute. Let me
0.99. Huh?
6259.
625.99.
625 only.
Yeah, 625.99.
Okay, 1 minute. So 681.81 minus 474 divided by what? 0.3147. How much?
625.99.
Okay, 6. So it is, I am getting 660 according to this value. 0.3147, na?
Yeah.
So it means what? A slope of this line will be what? Constant volume line slope will be what? See, here it must, we have a two option. This one or this one.
Yeah.
Upper one or bottom one. Out of that, which option we will take it?
Bottom one, I guess.
Why bottom one? Because the slope will be the less for this one.
Yes.
Why bottom one? Slope will be what? A less for this one. So that's why.
Yes.
So what we are going to, I am going to shape this one little bit further on this side. And then what we will have? 2 to 3 will be what?
Yes.
So this will be what? Our 2 to 3. Temperature of 0.3 is less as compared to temperature of 0.1. So this is what our polytropic process. So for polytropic process, PV raised to the power here what? 1.48 is equal to constant, and here we will say for this one V is equal to constant. You got it? Why slope is less here?
Perfect, sir.
So whenever there is a confusion between two curves, always try to help of the slope. And slope, how we will get a slope? Temperature difference, delta T,
Yeah.
divided by delta S. Means what? See, basic is what? Y2 minus Y1, X2 minus X1. See,
Yes.
delta Y divided by delta X. So delta Y is here, delta T. So from there we will get a slope. So always
Yes.
try to see this relation. So before going further, please write down this, please draw this drawing.
Yeah.